Hey guys, today we are looking at our notes for 7.5, which is all about factoring something in standard form that looks like x squared plus bx plus c. So with our 4 box of notes today, we're going to look first and try and discover a little pattern before we get into an actual factoring method. So if we're going to go through and do foiling, if you guys remember FOIL, we're multiplying our two binomials together. I can show you kind of the scratch work on this first one, but then I'm just going to kind of walk you through, or you can really do this on your own if you want to pause the video and go through and FOIL these out just as some extra practice. But if I go through and FOIL, remember FOILing tells me that I should be doing my firsts together. That gives me x squared. My outsides would be 4x. My insides would be 3x. And then my lasts would be 12. So when I collect up my like terms and put my answer in standard form, I should end up with a simplified version in standard form of x squared plus 7x plus 12 for that first one. So if I go through and do that for the rest of these, I'm going to clean that up a little bit because it'll help us in a second. If I went through and did this for x plus 1 times x plus 5, you can pause it and do this yourself, but you would end up with x squared plus 6x plus 5. Again, taking a look at x plus 9 times x plus 2. Again, you can pause and try it yourself. We should end up with x squared plus 11x plus 18. Some of you might be able to see a pattern so far. If not, I'm going to do a couple more, and hopefully that clicks for you in a second here. If we multiply x minus 3 times x minus 6, when I simplify that in standard form, I end up with x squared minus 9x plus 18. And then last but not least, x plus 7 times x minus 2 multiplies into x squared plus 5x minus 14. So those are our FOIL. Those are all of our binomials together. They're FOILed and in standard form. And I'm trying to figure out a pattern, because what we want to do is be able to take anything that looks like this. So here I'm just using P and Q to stand in for what those two numbers are, and B and C are just not going to be my coefficient on X, and C is going to be my constant. I'm trying to find a connection between the two things here that I multiply together and what I got in my answer in standard form. So if we look at my very top one there, I'm trying to figure out how I can use 3 and 4 to give me 7, and how I can use 3 and 4 to give me 12. How I can use 1 and 5 to give me 6, and how 1 and 5 would give me 5. 9 and 2 gives me 11. 9 and 2 gives me 18. So if I'm looking for a pattern here, if we didn't notice or haven't picked up on it yet, a lot of us probably have, if I was looking at 3 and 4, well, 3 plus 4 gives me 7. 3 times 4 gives me 12. So let's see if that works again. If I add my two numbers together, that should give me my middle term, my x term. So is 1 plus 5 6? Yeah, that checks out. Is 1 times 5 5? Yes. 9 plus 2 would be 11. 9 times 2 is 18. Okay, so that's working so far. Negative 3 plus negative 6. This one's a little tricky because I know some of us struggle with negatives. But if I add two negatives together, it makes a bigger negative. Negative 3 plus negative 6 is negative 9. And negative 3 times negative 6, two negatives multiplied together to be a positive. So 3 times 6 is 18. And then my last one, positive 7 plus negative 2 is a positive 5. Positive 7 times a negative 2 is negative 14. So that is my pattern. If I'm looking for how I can write this up, is if I'm looking for my B value, that is the sum of those two numbers in my parenthesis. My C value, that constant, the thing that's all by itself, is the product of those two numbers. So where that becomes useful is if we start with something that looks like this, if it looks like x squared plus something x plus something, or in that general format, If I'm trying to figure out how that factors, how those parentheses should look, kind of unfoiling stuff, I can see and try and figure out what two numbers add up to my b value, but multiply together to give me my c value. So that's going to be what we use for this particular type of factoring. So we're going to go ahead and, it might be easier for us to actually start visualizing some stuff. So let's hop in here to box 1, and we're going to give this a shot. So what we're asked to do again, if we're trying to factor x squared plus 10x plus 16, we can't use a GCF here because there's nothing in common between all three of them, so we have to go to a different kind of factoring, which is this new thing that we're looking at right now. So I'm trying to figure out if there is something, if there's two numbers that add up to 10, but multiply to give me 16. I'm trying to figure out if or which two numbers would do that for me. What I can multiply together to give me 16 that adds up to 10. So the way that I'll do this, and this obviously, the more you do this, the easier it will be, and the easier you'll be able to figure out these two numbers. And some of you are going to be very lucky, and it'll just make sense to you. You can see what those factors are right away of 16 and figure out which ones add up to positive 10. Others of us might have to write out what our factors are. So I usually will just make a little list here. We're looking for factors of 16, things I multiply together to give me 16. So I'll make a list, and then I can, once I have that list, it's easier for me to see which ones are going to add up to positive 10. So I know that 1 times 16 is 16, 2 times 8 is 16, and 4 times 4 is also 16. Those are my three different pairs of numbers that would give me 16, at least whole numbers. So I'm trying to figure out which of those pairs would add up to 10, or if any of the pairs would add up to 10. So if I added these together, that would give me 17. If I added these together, that gives me 10, so that's going to be the one I'm looking for. This last one adds up to 8. So that's why, in this case, this pair, 2 and 8, is that combination that I'm looking for. And the way that I would write this up, I would say that this factors out into x plus 2 times x plus 8. Because if I went through again and FOILed, I would end up back at x squared plus 10x plus 16. And again, that's the combination that works because 2 times 8 is 16, and 2 plus 8 is 10. And that's my pattern. That's it factored out. So let's try another one. Another one here. Now we're trying to factor z squared plus 7z plus 6. So once again, I'm looking for my two numbers to add up to 7, but multiply to give me 6. So I'm going to write out my list is going to be factors of 6. So I know to get 6, I could do 1 times 6 or 2 times 3, and that's the only combinations we have to get 6. So I'm looking to see if or which one of these adds up to 7. And of course, that first combination, 1 and 6, multiplies to get 6, but adds up to 7. So that is my factorization. Z plus 1 times z plus 6. And that's z squared plus 7z plus 6 factored out. Now, those ones are nice and easy because if you noticed, the title of that box was factoring with all positives. When everything is positive, we don't need to worry about my sign. All I need to do is just figure out my numbers, which ones are going to work. So as we get more or further in our notes here with box 3, we're going to get into some that are a little bit more complicated because we start dealing with some negative numbers. So if we look at number 3 here in box 3, we are trying to factor y squared minus 8y plus 12. So still same method. I'm still looking for what numbers could add up to negative 8, but multiply to give me 12. So if I look at factors of 12, I've got a few more options here. I've got 1 and 12 multiply to get 12, 2 and 6, and 3 times 4. So if I add these up, I get 13, I get 8, and I get 7. Which, no, okay, that's close, but I'm looking for, I want them to add up to a negative 8, not a positive 8. So I think 6 and 2 are going to be my combination here, but positive 6 and positive 2 would give me a positive 12, but if I added them together, it would also give me a positive 8. So what I have to do here, when you've got a positive product, so your factors, your product is positive, but you're going to have to try and add up to a negative, the way that that's going to be possible is if I make both of these terms negative. Because we know two negatives still multiply together to give me a positive, but now if I add those together, negative 1 and negative 12 is negative 13, negative 2 and negative 6 is negative 8, negative 3 and negative 4 is negative 7. So that tells me negative 2 and negative 6 is going to be that combination. So the way that I would write this out, it's just my variable, so in this case y, minus 2, and y minus 6. Because again, if I FOILed those two out, negative 2 times negative 6 is positive 12. Negative 2 plus negative 6 would be a negative 8y when I collect up my like terms. So that's what that looks like when you've got a positive c value. That number, that product is positive, but my sum, my b value, is negative. So we'll do another one of those, number 4. 4, again, we're trying to add up to my b value. We're trying to add up to negative 12, but multiply to give me positive 27. So I'm going to start out by listing out my factors of 27. And some of you, if you can't see all these factors right away, feel free to use a calculator. I know, again, we know that my math ability is very different than most people's math abilities, especially people who are just now taking Algebra 1. I took Algebra 1, I don't know, 15 years ago when I was in 8th grade. So, you know, I've been doing this for a hot minute. So don't feel ashamed to use a calculator just because I don't. Feel free to, test out different things and see what my factors are of whatever my C value is. So for 27, we know that we can do 1 times 27. We can do 3 times 9. And that's it. Because again, 9 times 3 and 27 times 1, it's the same thing. It's the same combination. But again, if I'm going to be a negative for my sum, I'm going to have to make both of those negative. So I'm going to try and figure out which one adds up to negative 12, which this is negative 28. 3 and 9 is 12. So that's the combination I'm looking for. Those are my two factors. So m minus 3 times m minus 9. And that's my factorization. All right, box 4, the trickiest part. The tricky one is when your c value is negative. Doesn't really matter what your b value is. If your c is negative, we've got a whole different issue that we're going to deal with. Because although it's the same process, I'm looking for what two numbers add up to my b term that also multiply to get my c term. The issue is that when I start looking at my factors of negative 21, looking at just the number side of things, 1 times 21 is 21, 3 times 7 is 21, and that's it, which is nice because it's a short-ish list. But if I want to be a negative 21, that means I either need to be negative 1 times a positive 21, negative 3 times a positive 7, but I also have the possibility of positive 1 times negative 21, and positive 3 times a negative 7. I have 4 different combinations, even though there's only 2 pairs of numbers that multiply to give me 21. Because again, if I want the product to be negative 21, it really matters, it really makes a big difference on which one is which. So now I have to look and see, all right, well, if I add these together, negative 1 plus 21 is 20. Negative 3 plus 7 is a positive 4. 1 plus negative 21 is a negative 20. 3 plus negative 7 is a negative 4. Now you notice here the number that they add up to is the same, but the sign just matches the bigger number. So the bigger number here being 21 and being 7, if that one was positive, my sum ended up being positive. And in the bottom two, if my negatives, my 21 and my 7 were negative, the sum ended up being negative. That's kind of a shortcut that you can use if you want them to be 4 apart, but you want it to be a positive that they add up to. Then you know that the bigger number just has to be positive. Eventually, that'll make sense, and as you get to be more experienced with this, that'll be what we're looking at here. But you can see, since we're trying to find the one that adds up to positive 4, this second one is the combination that works. A negative 3 and a positive 7 will multiply together to give me negative 21, but add up to a positive 4. So my factor is b minus 3, and my other one is b plus 7. And that is my final answer there. Okay, one more, last one here. Number 6. Now 6 is a little bit funky because I want to add up to what? And we want to multiply to get negative 42. So we've got to multiply. But again, I want to add up to something. I don't see anything here. We have to know that if I don't see a coefficient, there is a 1 there. So in this case, we're looking for something that multiplies together to give me negative 42 that adds up to negative 1. So I'm going to go ahead and list out my factors of negative 42. So we've got, let's see, 1 times 42, 2 times 21, 3 times 14, and 6 times 7, which means I have negative 1 times 42, negative 2 times 21, negative 3 times 14, negative 6 times 7, and 1, 2, 3, 6, negative 42, negative 21, negative 14, negative 7. So that's all of my different possibilities. Huge list here. So that would add up to 41. This one would add up to 19. This one adds up to 11. That one's positive 1. So then as I continue down my list, this is a negative 41, negative 19, negative 11, and finally, the very last one, we find our combination that adds up to negative 1. Very tedious in this case. So my final factorization there, positive 6 and negative 7, is my pairing. So v plus 6, v minus 7. The order that they're written in does not matter. You could have written this as v minus 7 and v plus 6. That's totally fine as well. As long as the two parentheses are correct, that's all that matters. All right, that's it for today. That is it for our regular, this is what I end up calling old school 2 parenthesis factoring, but it's just regular factoring for right now. Homework is up there on the screen, page 389, 4 through 24, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.